Hello, this is Mr. Huber. In this lesson, we're going to look at ellipses. You can see a couple diagrams there that show what an ellipse looks like. It's an elongated, stretched out circle, kind of an oval type shape. Okay, we're going to learn some key features of ellipses and how we can work with the graphs and equations of them. Okay, so you can see many things marked on these graphs. Okay, so those key features we want to be aware of are the vertices. Okay, we have a vertex here and here, for instance, in this horizontal ellipse. It's called a horizontal ellipse because it's stretched out horizontally. Okay? This is called the major axis. Between the two vertices is called the major axis. Okay? In the vertical ellipse, the major axis goes up and down because this is stretched out vertically along the y-axis. Okay? The vertex will always be the a value. Okay? So the vertex is further away from the center than the covertex. The covertices are the other kind of sides of this ellipse. Okay? It's like a radius along the major axis and a radius along the minor axis, if you will. Okay, but it's not the same. Like in a circle, these would be the same distance. Now they're not the same distance. Okay? And then you have the focus. Okay? The focus is a point inside the ellipse, and you can see there's a value for the vertex, B value for the covertex, C value for the focus. They're going to be our keys. All right? Those are our three key features. Whereas the vertex, covertex, and focus. Vertex, covertex, focus. All right? And however far the vertex is away from the center, it's the same on the other side for the other vertex. Right? There's two vertices, one on either side of the center. One on either side of the center. Okay? So if this point is at 5, 0, this point would be at negative 5, 0. And we can do the same with the covertices. Right? And those A and B values are going to be what we use to write our equation. It's x squared plus and a y squared in both of them. They're always equal to 1, so always equal to 1. And then you'll see the difference is the A and B values have switched. Okay? The A value is always bigger than the B value, so depending on which axis it's stretched out on, here we're stretching out along the x-axis horizontally, the A value will go under the x. Here, the A value will go under the y because it's stretched out vertically. Okay? So that helps us difference between a horizontal ellipse stretched out along the x-axis and a vertical ellipse stretched out along the y-axis. So the A value will go underneath the x or y depending on if it's vertical or horizontal. And for that focus, the C value, right, we can use this equation here. C squared equals A squared minus B squared. So we can use that to find a C value, or if we know the C value and the A value, for instance, we could find the B value. If we know two of them, we can use that equation to find the third value. The A and the B are the two we need for our equation, but sometimes the C would be useful for drawing the graph. And also if we know the C value, you can use then C squared equals A squared minus B squared to get the A or the B to put into our equation. So let's see some examples of what we can do with these. This first example is we're going to write an equation of the ellipse centered at the origin with a vertex at 7, 0 and covertex at 0, negative 4. I'm just going to draw a quick sketch of what this might look like. Okay. So the vertex, let's say, is out here at 7, 0. That means the other vertex, would be over here at negative 7, 0. Covertex at 0, negative 4, 0, negative 4. We'd have the other covertex here at 0, 4. Right? Same distance from the center. So when we look at the vertex here at 7, 0, on this side would be the other vertex. Okay, in our ellipse, again, just a general idea of what it looks like, something like that. Okay. So that gives us an idea. It's stretched out horizontally, right? So it's stretched out here horizontally. This would be our A value, 7. This would be our B value, 4. It doesn't matter, we can go this way, it's a distance of 4. And we're going to square it in the equation, so if you wanted to put in a negative 4, even in squared, it's still going to come out positive. You don't need to worry about that because you're going to square them. So when I write the equation, I'm going to have x squared and y squared and equals 1. That's not changing. Okay? Now I need to put in an A value here, because it's stretched out horizontally, that's my 7. So 7 squared, that's going to be 49. Plus y squared over 16. So there's my equation of the ellipse. x squared over a squared, my a value is 7, plus y squared over b, my b value is 4, and then equals 1. All right. Now let's look at the next one. And one thing you're going to notice from this graph is that, erase that line there. One thing you'll notice from this graph, or this equation, excuse me, we're going to try and graph, is that it doesn't equal 1. So that's the first thing we need to do, is get this set equal to 1. We can do that by dividing both sides by 225. And when we divide both sides, we divide everything on both sides by 225. So what this is going to give us now is x squared over 9. 25 over 225 would reduce to 1 over 9. Plus y squared over 25 equals, now it's 1. 225 over 225 is just 1. So I can get from this my a and my b values. We see the bigger number under the y squared. That's where I'm going to get my a value from. So my a value is 5. Remember, that's 5 squared. My b value is 3. Okay? So we can graph this. All right, I'm going to draw in my coordinate grid here. Right. And I'm going to count by ones. And so my a value 5, vertical. It's going to go stretch out vertically. So I'm going to go up to 5, 0, 5, and then down to 0, negative 5. There's my vertex and my vertex. Okay. My co-vertices are going to be a distance of 3 away from 0. So that's my co-vertex and co-vertex. I could draw in an ellipse now. It goes through those points. Okay. And if you notice back up in the directions, we want to identify the foci. Okay. So there's focus on both sides of the major axis. So we're going to have a focus somewhere over here and a focus somewhere over here. So to find those is where we're going to have to use my c squared equals a squared minus b squared. Okay? So I'm going to set up c squared equals a squared minus b squared. Okay? So it's going to be c squared equals 16, which means c equals 4. So now my focus will be right there and right there, a distance of 4 from the center. So I've got my graph drawn, I got my foci labeled, I've got my vertices labeled, I've got my co-vertices labeled, and I'm good to go. Remember, though, we have to get it set equal to 1 if it isn't already. Okay? So now, let's look at a third problem here. Some different information given, but still working with that same basic premise of the equation of the ellipse. What's the equation of an ellipse centered at the origin with vertices plus and minus 10, 0 and foci plus and minus 8, 0? So again, a quick little sketch can be useful here so we have an idea of what we're working with. So we're going to have 10, 0, negative 10, 0. That's my vertices there. Okay. The focus, okay, is at 8, 0 and negative 8, 0, right, plus or minus, okay? So I've got my a value, because it's a vertex, so the vertex of 10, 0 means that's the major axis. So my a value is 10, and my c value is 8. So let's write that out. So my a value is 10, my c value is 8. We're trying to write the equation for this ellipse. Okay, the equation for it means we're going to need the b value. So we're going to have c squared equals a squared minus b squared. We need the b value to write the equation. So we have 64 equals 100 minus b squared. So it's negative 36 equals negative b squared. So we divide both by negative 1, and we get b squared equals 36, which means b equals 6. So now I've got the two values I need to write my equation, a and b. Okay, so I can write the equation. Will be x squared plus y squared and equals 1. That's not changing. Now my a value goes under the x. It's stretched out horizontally, so that's 100 because it's 10 squared. And underneath y squared will be the b squared, which is 36. So there's my equation. X squared over 100 plus y squared over 36 equals 1. Right? Again, we need two values to write the equation, a and b. Remember how we can relate them with the c value when we need to work with that as well. So now let's take a little musical interlude. What artist or group has had the most #1 singles in Billboard Top 100 history? All right, we'll start to reveal here. It is a group, not a singular artist. So let's see if we can figure this out as it starts to come into picture here. Any guesses yet? It is the Beatles. The Beatles had 20 #1 songs on the Billboard Top 100, and their longest running was Hey Jude, which was #1 for 9 weeks. So the Beatles have had 20 #1 songs, the most of any artist or group. All right, let's get a couple more problems here. Dealing with ellipses. Again, you should be trying to work these out, seeing where you're understanding it as we're going. So for number 4 here, it says find the distance between the foci of an ellipse. So we need to figure out where the two are, and then we can find how far apart they are. Okay? Major axis, length 15. Minor axis, length 12. Okay? So if the major axis has a length 15, that means the a value is 7.5. Okay? Because the major axis is the distance from vertex to vertex. So the a value is from the center to just one of those vertices. Okay? And a minor axis length 12, so that means we have a b value of 6. So now we can set up c squared equals a squared minus b squared. Okay? That's c squared equals, and if you do 7.5 squared minus 6 squared equals 220.25. So that means c equals 4.5. We square root that, right? To find out what c is, square root both sides. So c equals 4. So the distance between the foci, okay, is going to be 9. And if I drew this out, if I have an ellipse, and it doesn't matter if it's horizontal or vertical, if I have an ellipse like this, and here's my center, and it's a distance of 4.5, right there, if that's 4.5 for my c value, then my other focus, or if that's a focus, my other focus will be on this side of the center, 4.5. So my distance from here to here then is 9. So again, pay attention to the different information we can be given. We're still working with those same basic premise of the a's, the b's, the c's. Know what it means to have an axis length or an a value, how those relate to each other. Right? The axis is the whole distance between the vertices. Minor axis, whole distance between the co-vertices. Okay? So understand how that relates to our a's and b's and c values. All right? Let's see one more here. We're going to write an equation of an ellipse, centered at the origin with foci plus or minus 5, 0, and co-vertices 0, plus or minus 12. Okay? So from this, right, let's first just look at what information we have. This is our c value is 5, and our b value is 12 co-vertices. Right? So that's our b value. So we could do 5 squared equals a squared minus b squared. So from this, we would get 25 equals a squared plus 144. Excuse me, minus 144. Sorry, we gotta change that. I'm already thinking about adding it to both sides. Okay, getting a little step ahead of myself. Okay, now I'm going to add the 144 to both sides. And I'm going to get 169 equals a squared. So that means a is 13. So now I can write my equation. Okay, my equation is going to be x squared, y squared, and equals 1, right? All I'm finding here is my a's and my b's. That's what I need to use to plug in for my a and my b underneath the x and the y. We want to recognize which way is this going, right? The co-vertices, 0, plus or minus 12, that's a y value. Okay, if a little sketch helps, we draw a little sketch here. Co-vertices at 0, 12, and 0, negative 12. So that means the vertices, okay, are going to be here and here. Right? Negative 13, 0, for instance. And 13, 0, because it's a distance of 13, right? We found our a value here is 13. That's our a value. So it's going horizontally. That means the bigger value goes underneath the x squared. Okay, so we're going to fill in here, and we're going to have 169. and 144. Because remember, square them, a squared and b squared. So there's our equation for that ellipse. Equation of ellipse centered at the origin, and we give it a focus and a vertex. We can use those, again, to find the a value. Okay? And then we have our a and our b, which are the two things we need to write our equation. So you've seen some different examples of things we can do with the ellipses, all, again, based on that x squared, y squared over the a squared and b squared. Know if it's horizontal or vertical, that it's stretched out, always equal to 1. And how we can work with the focus as well, either if we need it to draw the graph or we're given the information we can use to get that c squared equals a squared minus b squared and get the information we need. All right, so some different examples, some different things there. Make sure you're practicing, taking that Schoology quiz, and getting ready to go, continue working on ellipses.